All right, so yesterday when we did the radicals, they were all perfect roots, like perfect squares, perfect cubes, perfect fourth powers. Today they're not going to be that, so we have to talk about how we're going to simplify those. We don't want decimal answers. We want to leave everything in what we call simplest radical form. So let's start with the first one. What kind of root are we dealing with? Square root, cube root, or fourth root? Square root, okay? So I'm going to look on my list. Okay, this is where our list is really good. And we notice that 27 is not on our list, correct? So when we do this, we simplify. We want to make sure we get the largest perfect square out of this. And so the way that I found is the easiest, so that you don't have to go through too many, is we're going to go to our list. We're going to find the closest number to 27 without going over, and that would be 25. And then I'm just going to start here, and I'm going to work my way backwards until I find one that goes into 27 evenly. Maybe. Try this again. All right, so again, we're going to go to the number closest to 27 without going over, and we're going to see if it divides in evenly. Does 25 divide into 27 evenly? No, and then I'm going to just work my way up the list until I find one of my perfect squares. I know a lot of you probably already know what it is, but when we get to some numbers that we're not comfortable with, we can do this same method. Then I'm going to go up to 16. Does 16 divide into 27 evenly? No. Then I'm going to go up to 9. Does 9 divide into 27 evenly? It does. So what we're going to do is we're going to split up 27 into my perfect square first, which we said was 9. And then what is it that I multiply 9 by to get 27? 3. So we're going to go the square root of 3. Okay, so I split 27 up into the perfect square times whatever it takes to get to that number 27. And then I can simplify the part that is my perfect square. So the 9, what is the square root of 9? Okay, so that turns to 3. And then this square root of 3, it does not have a perfect square in it. And we don't know the value of it without a calculator. So we're just going to keep that behind that other 3. And the answer is going to be left like that, 3 square roots of 3. Does that make sense? All right, let's take a look at the next one. What kind of root am I dealing with on the next one? Cube root. So I'm going to go to my cube list. I want to find the number closest to 16 without going over, which is 8. And I'm going to ask myself, does 8 divide evenly into 16? It does. So I'm going to split this up into the cube root of 8 times the cube root of 2, because 8 times 2 gives me 16. I always list my perfect root first so that I don't put them backwards. A lot of times people put them backwards and it just gets a little confusing. So if you get in the habit of putting your perfect square, perfect cube, perfect fourth power first, then when you simplify that, that radical is going to disappear. What is the cube root of 8? 2. So that first part is going to turn into a 2. And then the other part cannot simplify any further. One thing you need to make sure of, and this is something that happens every year, is we forget the little index, okay? If you don't put that index there, you're telling me it's 2 times the square root of 2, which is a whole completely different number. So make sure if you have an index other than a square root that you put that in your answer, and we're going to leave it just like that. Everybody okay with that one? All right, 3 is similar, but it also has a number in front. Is that 4 an index? No, it's not. It's big, and it's in front of it. It's not a little one up in that little space there. So this is 4 times the square root of 32. So what we're going to do is we're going to think about the 32 first. We're going to just leave this 4 out front for now, and it is going to get multiplied by whatever we bring out of 32. Am I dealing with a square root, cube root, or fourth root here? Square root. So I'm going to my squares. 32 is not on my list. So I go to the number that's closest to 32 without going over. Does 25 divide into 32 evenly? Okay, then I go up. Does 16 divide into 32 evenly? It does. So we're going to split that up into square root of 16 times what? 2. Okay. 32 is one of these numbers. If we don't work our way backwards, so we're going to find, because 4 also goes into 32, but if you use 4, it's not completely simplified. So that's why I always say start and work your way up. That way you'll always guarantee that you get the largest perfect square. All right, I'm going to keep the 4 in the front, and then I'm going to simplify. What is the square root of 16? 4. And then that square root of 2 is going to stay. And then all I have to do is multiply those two numbers in the front. 4 times 4 gives me 16. So my most simplified answer for that one is going to be 16 square roots of 2. So we're going to clear that. Okay, let's take a look at number 4. Now, if you remember yesterday when we did the numbers and the variables, we think of them separately. Okay, so what we're going to do is we're going to start with the 49 first. What root am I taking? The square root. Is 49 a perfect square? It is. So that's going to simplify to be just what? Okay, so I'm going to think about it like this. And then as far as the variable goes, what's the exponent on the x right now? A 1. And what is my index that's not written? It's a 2, right? Does 2 fit into 1 evenly? It doesn't, does it? What that means is that x to the first does not have a perfect square in it, so it cannot be simplified, which means it's just going to be brought down right behind that 7 and left under the radical sign. Okay, if you think about x to the first, under a square root, there's only one x. I can't get any pairs of 2, so therefore I cannot simplify it, and it stays where it is. Is everybody okay with that one? Okay. All right, let's take a look at 5. I have the square root of 18x squared y. We're going to start with the number first. Is 18 on my perfect square list? No. So again, we go to the closest number without going over and ask, does 16 go into 18 evenly? No, we're going to go backwards. Does 9 go into 18 evenly? It does. Okay. So we're going to split this into the square root of 9 times the square root of 2, and we're going to deal with the variables in just a minute. What is the square root of 9? 3. Okay, so that's going to turn to just 3. And what I'm going to do is I'm going to leave a little bit of space. I'm going to keep that 2 under the radical. And why I'm leaving some space is because I still have some variables that I have to deal with. We're just going to deal with them one at a time. All right, let's go to the x's. I'm focused on the x's only. Remember my index out here that's not written as a 2. Does 2 divide into 2 evenly? It does. How many times? 1 time. So that 1x is going to come out front with that 3. And then I'm going to deal with the y's. What's the exponent on the y? 1. Does 2 divide into 1 evenly? No. So where does that y need to go? In the front of the radical or under the radical? Under the radical. It cannot simplify. So our answer is going to look just like that. 3x times the square root of 2y. So far, so good? Kind of, maybe? If you need to do it separately, this would be another idea. We could split it completely up. We could do the 18, the x squared, and the y, and then we can bring our answers together, okay? So what I mean by that is we would do the 18 just like we did, and that would become 3 square roots of 2. This one, remember, it divides in evenly, so that would just become x to the first. And then this one doesn't divide in, so it would stay under the radical. Everything that's not under the radical, I multiply in the front. Everything that's under the radical, I multiply and keep it under the radical. That's kind of what we did. We just didn't write it down separately like that. If it helps you to split it out like that, you can do that. Just make sure everything that's not under the radical anymore is multiplied at the front. Everything that is under the radical is multiplied and stays under the radical. All right, let's try 6. What kind of root am I dealing with? Square root, okay. So my index is a 2. How many times does 2 divide into 3? Once, but I have leftovers, right? So it divides in evenly once. That's going to come out from under the radical. And how many leftovers do I have? 1. And that's going to stay under. Let me show you that a little bit differently. If we think about this, x to the third. Okay. My index is 2. That means I want 2 x's in every group. There's only one group of 2. That's the one that came out front. This one that's left over has to stay under the radical, and we can leave it like that, or just x square roots of x without the 1. Anybody have any questions on that one? You got it? Mm-hmm. Right, I want you to try those three. We are simplifying the square root of x to the fifth. So I'm going to do it the short way and then I'll do it the long way. And it doesn't matter to me, whatever you're more comfortable with is the way that you should do it. What's the index on a square root? 2. Okay, so how many times does 2 divide into 5? Twice. So those 2 are going to come out. And then what's left over? How many? One of them? Okay, let me show it to you the long way. If I think about this, the square root of x to the fifth, that's x 5 times. Because it's a square root, I want groups of 2. I only got 2 groups of 2 x's, and I have that one left over. So that's how it works. So if you need to write it out like that and circle your groups, do that. I would rather you do that and take a little more time and get the right answer than I would for you to try to rush through it and not get the right answer. Are you okay with that? Okay. Let's look at number 8. I want the square root of 24x to the third y. Let's start with 24. Is 24 on my list? No. So we're going to go to the closest number to 24 without going over. Does 16 divide into 24 evenly? Does 9 divide into 24 evenly? Does 4 divide into 24 evenly? So we're going to start by splitting that in. The square root of 4 times what? 6. I'm going to simplify the square root of 4 into 2. Again, I'm leaving some space because I'm kind of doing it all, but you can split it up like this if you want. I'll show you that in a second. Now let's move on to our x's. How many times does 2 divide into 3? 1. So that one's going to come out. Do I have any leftover x's? How many? 1. Okay. And then let's look at the y's. Does 2 divide into that 1 evenly? No. So that y is going to have to stay under the radical. So it should be 2x times the square root of 6xy. And again, if we wanted to do that individually, we would do the square root of 24, the square root of x to the third, and the square root of y. And again, we would use the 4 times the 6. That would turn into 2 square roots of 6. 2 goes into 3 one time with 1 left over. And 2 does not go into 1, so that stays where it is. And then just remember what I said. Everything outside of the radical, everything in front gets multiplied, so 2 times x. And then everything under the radical gets multiplied and stays under the radical. And that's how we end up with that answer. So far, so good? Number 9, we're looking for the cubed root of 54. So I need to go to my cube list. Is 54 on my list? No, so I want to go to the number closest to 54 without going over, which happens to be 27. Does 27 divide into 54 evenly? Yes, it does. How many times? 2. So we're going to split that up into the cube root of 27 times the cube root of 2. And then I'm going to simplify. What is the cube root of 27? 3. And then that cube root of 2 is going to stay where it is. Getting the hang of it, kind of? All right. Okay, we're going to do the cube root of 8x to the fifth. Let's start with the number. Is 8 a perfect cube? Yes, it is. So I can just take the cube root of it, and that turns to 2. And then we have to deal with our variables. How many times does 3 fit into 5? 1 time, so that 1 comes out. And how many would be left over? 2. Make sure you put your index in that answer. If you don't put your index in the answer, it's a completely different value. Okay, so your answer should be 2x times the cube root of x squared. Now I want to show you how to write it out, though, in case that's the way you're working on these. Because it is slightly different because of my index. X to the fifth is 5 x's. The index tells you how many you want in each group. And so since this is a 3, I want a group of 3, okay, but there was only one of those. And then my leftover, that's what stays under the radical. Does that make a little bit of sense? So if the index were 4, I would want a group of 4. All right, and then for 11, I don't have any numbers to deal with. And we can do this both ways. How many times does 4 divide into 7? 1 time. And then how many left over? 3, okay? Again, don't forget your index of 4, because if you lose that, that is telling me something completely different. And this is the long way. 5, 6, 7. Because the index is a 4, again, I want a group of 4 this time. There's only that one group, so that's what came out. And then I have those 3 that are left over and stay where they are. And that's how we got that answer there. Kind of okay? Somewhat? Okay. All right, so when we have problems like number 12, we're multiplying radicals. 6 square roots of 6 times 4 square roots of 10. This is how you do it. Whatever numbers are in front of the radical get multiplied together. So what are the numbers in front of the radical? 6 and 4. So I'm going to multiply 6 times 4. And it's going to stay outside of the radical in front. And then I multiply the 2 numbers that are under the radical. The 6 and the 10. And they stay under the radical. What is 6 times 10? 60. And then from there, I need to see if it can simplify. Is 60 on my perfect square list? No. So what I need to do is go through and find a perfect square that divides into 60. Again, to get the largest one, we want to go to the number closest to 60 without going over, which is 49 on my list. Does 49 divide into 60 evenly? No. Then I go up. Does 36 divide into 60 evenly? Does 25 divide into 60 evenly? Does 16 divide into 60 evenly? Does 9? Does 4? How many times? Okay. So we're going to keep the 24. We're going to split that 60 into 4 times 15, because 4 times 15 gives me 60. We're going to keep that 24 for now. We're going to simplify the square root of 4. What is the square root of 4? 2. And that 15 is going to stay under the radical because it is not a perfect square and it does not have a perfect square in it. And then the last thing we do is just multiply the 2 numbers in the front. 24 times 2 is 48. So my most simplified answer is going to be 48 square roots of 15. So multiply the numbers in the front, multiply the numbers under the radical, and then try to simplify from there. Are we okay with that? All right, I want you to try both 13 and 14. It's the same process, except for I have cubes and 4th roots. So multiplying and then simplifying. Okay, with 13, I have the cube root of 3 times the cube root of 18. They are both cube roots, so I can multiply. They don't have anything in front of them besides a 1. So all I do is I multiply the numbers under the radical. The cube root is going to stay the same. What is 18 times 3? 54. Okay, so now I want to simplify. 54 is not on my cube list, so I'm going to go to the number closest to 54 without going over, which is 27. And I think we just did this one a few minutes ago. Does 27 divide into 54 evenly? It does. How many times? 2. So I'm going to split that up into the cube root of 27 times the cube root of 2. And then what is the cube root of 27? 3. And then that cube root of 2 stays the same. Don't forget your index of 3. If you forget that, you're telling me the answer is 3 times the square root of 2, which is a completely different number. All right, and then 14, I have the 4th root of 6 times the 4th root of 8. They are both 4th roots, so I can multiply. What is 6 times 8? 48. But this time, which list do I want to look at? The 4th, okay? The closest thing to 48 without going over is 16. Does 16 go into 48 evenly? How many times? 3. So I'm going to break that down into the 4th root of 16 times the 4th root of 3. And then what is the 4th root of 16? 2. Okay. So your answer would be 2 times the 4th root of 3. You're kind of okay there. All right. I want you to try 15, and then we're going to have to do 16 and 17 together. Okay, try 15. I don't have any numbers out front. I want the cube root of 4x squared times the cube root of 4x to the 4th. So let's first start by multiplying those. What is 4x squared times 4x to the 3rd? 16x to the 5th, all right? Now, let's start with the 16. Is 16 on my cube list? No. The only perfect cube that could go into it would be 8. Does 8 go into 16 evenly? Yes. So we're going to split that up into the cube root of 8 times the cube root of 2. And what is the cube root of 8? 2. And again, I'm leaving some space because I still have my variables to deal with. And then I'm going to look at it like this. How many times does 3 divide evenly into 5? Once. And how many leftovers would I have? 2. So the answer would be 2x times the cube root of 2x squared. Go with that one. Okay. You forgot the one group. That one circle has to come up front. And then the leftovers stand. So there should be an X right there. And then don't forget your index. All right. So with 16 and 17, here's a couple of things. With radicals, you are not allowed to leave a fraction under a radical sign. You are not allowed to leave a perfect square under a radical sign or a perfect root under a radical sign. And then you're also not allowed to leave a radical sign in the denominator of a fraction. Okay, so right now with 16, I got 1 over the square root of 2. Now, you know how the fractions, like, for example, if I had 6 over 9, you know how we can divide them both by the same thing and it's still the same fraction? Okay, well, it works the same way going with multiplying. We can multiply the top and the bottom of a fraction by the same number and it still stays the same value. So what I have to figure out is, how can I turn that square root of 2 into a non-square root? Okay. What can I multiply the square root of 2? So basically, I need to turn that denominator into a perfect square, right? Yeah, I'm going to multiply it. In order to turn 2 into a perfect square, I'm going to multiply it by itself, basically. I'm going to multiply it by the square root of 2. And if I multiply the denominator by the square root of 2, I have to multiply the numerator by the square root of 2 as well. This is what we call rationalizing a fraction. What is 1 times the square root of 2 at the top? Just the square root of 2. And then the square root of 2 times the square root of 2 turns into the square root of what number? 4. And then we're going to try to simplify. Okay, does 2 have a perfect square in it? No. And then what is the square root of 4? 2. Can I simplify the 2 under the radical with the 2 that's not under the radical? No. You can only simplify if they're both in the same place. Because the top 2 is underneath that square root sign, it cannot be reduced with that bottom 2 that is no longer under a square root sign. So we leave our answer just like that. So anytime you have a square root in the denominator of a fraction, to get rid of it, you basically multiply it by itself. That turns it into a perfect square. You multiply the top and the bottom, and then you simplify as much as you can. So with 17, I've got 3 over the square root of 7. If I wanted to get rid of that square root of 7, what would I multiply the top and the bottom by? Square root of 7. Okay. So let's start there. One thing we have to point out, though, when we do this. When I multiply at the top, okay, is 3 under the radical? No. So when you multiply a number that is not under a radical with a number that is under a radical, you can't actually multiply those. I would not get the square root of 21 there. I would leave it as 3 times the square root of 7. That radical is like a barrier there, okay? You cannot actually multiply them and get 21. Now at the bottom, because they are both under the radical, we can multiply them. 7 times 7 is what? 49. And then I'm going to look at seeing what I can simplify. Does 7 have a perfect square in it? No. And what is the square root of 49? 7. Is there anything I can simplify there? Does the 7 under the radical simplify with the 7 in the bottom? No. So we would leave our answer just like that.